but that doesn't let us do cool stuff like make dependency graphs based on real traffic and do aggregations and get average real latencies based on our traces, stuff like that. That doesn't work. Our plan was to use Dataflow and just iterate over the chunks in our bucket, which works, sure, but it's going to get really complicated as compression gets added and a bunch of other things come in. So that's why I was like, I want to read more about this query frontend so I don't have to deal with Dataflow.
Very cool. That's like pretty cool. So Joe added compression here, so he's to blame for all your troubles with not being able to parse blocks with compression. But I don't know how much the query frontend can help with that. I mean, really, it's designed to be something that can help to scale out the query path. So what the query frontend does today is split each incoming query into shards. And each shard is basically a range of blocks that it's like, so every block has a UUID, and the shard says search between this range of UUIDs. And so the queryers pick each of these smaller shards and then work on them in parallel. And if we have multiple hits with the different queryers, they'll send all of these results back to the query frontend, which will merge all of the split traces and then return that whole trace.
I see. Okay. So I misunderstood what the querier did then in that case. I guess what I'm talking about is more, we have a query language similar to PromptQL and then be able to do stuff with that, which is another different ballgame entirely, even though it's the same word. Yeah.
Yeah, you're a couple steps ahead of us, but we've been talking about that, how that could work with Tempo, how we can do that with our existing backend, what we would need to add or change to make that work. So yeah, that's kind of on our long-term roadmap, but it's certainly nothing that's going to happen in the near future. But we generally want to kind of make a few. I think there's honestly a very short list of changes to really feel comfortable with the key value store being in the millions of spans per second. And we're already kind of working on maybe design docs or floating around ideas about where to take it next. And definitely query language to do search and metrics is on this long list somewhere.
That makes sense. Looking at the next version of Grafana, I can also see super interesting synergies, but like they're making this dependency panel, right? Which could tie super nicely if you could have a Tempo QL query that can actually give you that and then display it directly in Grafana and stuff like that. You could do lots of interesting things with that data.
The service graph would be hard. So when I'm thinking of a query language, I'm thinking of things like give me, a P99 of a certain span, latency over a given time period. To generate a query graph, though, you would need a different kind of question, right? You need like, what are all the connections between all my services? It would be a different kind of query. I'm thinking more like a time series query, right? A query that results in, some kind of TS or time series data. That's a different query. That's very interesting. I wonder if something more like what you all are. I think the direction you're going might be a more appropriate direction to generate something like that. Like either kind of do a batch job or like kind of live calculate it as it comes in and just store some kind of value somewhere. I don't know.
Yeah, that's one option. Another option is to have some kind of query language where you could say, give me all the trace data for these criteria, and then you can process it like you want, right? And you just do any aggregation that you might want to do as long as you have some kind of starting point, like give me all traces that include this service, and then you can kind of go from there. Since like if you know your critical path, which you usually do, and then you can query, okay, give me all traces including any of these services, and then you can find their dependencies and actually generate something useful out of that. Or you can do it on AJS, like you said, which that does have the disadvantage that you have some lag. Like you write your query and you need to wait X amount of time until everything is there.
So for a query to do that, like say you wanted to write a query, that's a good idea. Like I want to ask the question of what services or what traces include this service and kind of start building a dependency graph via that. I think the issue with that is just the sheer amount of data you would need. I mean, we take, I think, something like 7,000 to 8,000 traces a second. And if you were to want to generate a dependency graph, you would need to see a good percentage of those. So let's say you want to generate a dependency graph for the past hour, that's 8,000 times 3,600. That's a whole bunch of data to request from the back end and then start doing some kind of work on it. I think a really cool path here might be, so the collector, the Open Telemetry collector, which the Grafana agent is built on, or at least only the trace pipeline and the Grafana agent is built on, already has kind of this PR up to add a metrics processor where they would calculate metrics live based on span streaming through. I think it'd be really neat to extend that or add a new processor, work with that community to add a new processor that would generate the data necessary for a dependency graph, store it in Redis or something, who cares, and then query it out of there.
That makes it harder though, because you have one per cluster, right? So suddenly you're at the question of, cool, Tempo has my full traces, but my cloud agent doesn't. So as soon as you're tracing a cross-cluster request, you're making your life really hard if you do it on that level.
That's true. That would not work well for cross-cluster work unless you had some kind of centralized data store, right, that you're putting this all in. I don't know. That's a good point.
Which is Tempo, right?
That's fair.
Would you say your dependencies, like your dependency graph, is kind of stable over time, or does it, like, how much change is there? Like, let's say over a given day or an hour.
Yeah, it's mostly stable. The main value I see in running this regularly is that you can notice when someone sneakily adds a dependency or accidentally adds a dependency. That's why you want to run this, for example, on a weekly basis. But it's not like this thing that you won't need to calculate every minute, right? It's more, okay, every week I want to take I'm going to take 1% of the last week's worth of traces and just have it roll through and see what I get, so something along those lines. And then the challenge is getting a representative set of traces to actually do that with. You can obviously take them all. That's the obvious answer. But if you can have some kind of query language where you can somehow get a representative sample, that's better.
Right. Yeah, Amazon X-Ray has a service graph that is built up, but it requires a time range, so it's kind of similar. So I mean, it's how, for this given time range, here's what the dependencies look like. So dependencies change over time and things. Yeah.
That's fine.
Now, Joe, like, do you know about the Jaeger dependency graph, how it's generated? Is it across all time? Is it maintained like statically outside and added to, or is it within a time range like how X-Rays is?
I know you run like a batch job, and then it just runs continuously in the background. It took like a day to calculate it over our data, which was significantly smaller than our current data. I never really dug into it. I never really saw how it was like the past hour or day or what it was even trying to do, but it just stored it in the same Cassandra cluster as our normal Jaeger data. And I think it took like a full 24 hours to do like a single run to generate the new like dependency graph. And we didn't get a lot of value out of it, frankly, so we turned it off.
Yeah, and in our case, it's also not just about the dependency graph. It's also about, okay, what can I expect will happen if this thing breaks? You can do all kinds of fancy things once you have a dependency graph, like computing aggregate SLAs. But the SLA of this thing is that, and the SLA of this thing is that. What can I expect of the thing that uses both? And stuff around that level that we actually think is pretty useful. It's true that if you don't do anything with the dependency graph, it's not useful on its own. It's more of a starting point to do more things with.
Cool.
And now the question about using it at the querier makes more sense, right? Like that seems like the best place where you can sort of stream this data and calculate your dependencies and then generate this sort of graph. It seems like a good thing to play with.
Yeah, I really like the idea of what you're trying. Luna, are you with, I think I was just told about somebody who's writing batch jobs against Tempo data.
That's us.
Okay. All 400,000 companies doing that. Embark, is that right? Okay,
That's
cool.
us indeed. Yeah.
Very cool.
Studios.
It's such a neat idea. I'd really like to meet with your engineering team and see what you all have done and get some idea of what's going on there. I really like the idea of batch jobs for this. When I was thinking, when I was thinking of query language, I wasn't really thinking of something that would fill this need. But if it is a need, we need to kind of document it. Do you all mind maybe writing up an issue on the repo, kind of showing the work you all have done and kind of saying what you all would like, and we can use that to kind of document a feature like Service Graph and how Tempo could support that, and maybe use that as a running document going forward?
Sure, gladly. The person who's done most of the work on this is actually my boss or director of infrastructure and services, who did a bunch of stuff like this at DICE. So I'll hit him up and ask him to write something up and
very cool.
do that.
Yeah, it's a neat idea, and it was not the direction we were thinking. So definitely getting it documented would be great. So we can kind of keep an eye on it and think about how we could do it ourselves as well. Roll it up into Tempo. What language is it? Is it Dataflow? What's Dataflow?
So Dataflow is this Google thing that essentially lets you iterate over things in the GCS bucket. And since chunks are stored in the GCS bucket and have a fairly easily decoded fixed encoding format, easy, right? You just write a small Java class that can extract data out of them, and you're golden.
Very cool.
Obviously, we knew that was going to break, right? As soon as the data format becomes more complicated and you start looking at encryption or compression and all that stuff, that falls apart, which is fine.
Sure.
So that's why my thought was more like, okay, can we have a thing that basically, like, it could be as simple as a gRPC endpoint that just streams traces to you, right? In a fixed format. Like, it doesn't have to be complicated, but just something to get data. And you can batch process the rest, essentially.
It would have to be downsampled in some way, right? Like, if you'd have to build a whole thing capable of taking your entire trace, fire hose
Probably,
data.
yeah. Either filtered or downsampled, or both.
Right.
Hence why my thought was immediately, can we have some query language that lets us do this?
Yeah. It's just hard. So what we've been looking at, when we talk about query language, what we've been looking at is just the amount of data we have to scan to answer questions, right? We're currently, what are we at? Close to 50 megasecond in Proto? Is that right? Yeah, something like that. And then, 50 megasecond times 3600 is going to be, 180 gig in an hour, 175 gig in an hour. So to answer a question over an hour, definitively, you'd have to scan 175 gigabytes of data. Looking at some internal Loki metrics, I think they were hitting they're hitting like around 10 gigs a second. Is that what we saw, Marty?
I thought it was maybe a little bit less than that, but yeah.
Sure. Let's just say 10 gig.
Yeah.
So that would be 17 seconds. Is that terrible? That's not terrible. 17 seconds to answer a question over an hour, to scan a full hour's worth of data. And that's without duplication, without replication factor, assuming you perfectly compacted your time period. That's a little bit more than I want. Like, for an hour query, you're in a Grafana and you type an hour query in Cortex or Prometheus or whatever, and it's going to come back basically instantaneously, like no delay. But I don't know if we can set expectations different for the amount of data that's being scanned. And also just the sheer amount of data that has to be returned. If you just were asking for everything, that'd be crazy. You'd be asking for our 175 gigs of data so I could go build a service graph somewhere.
Yeah, absolutely.
So I think I think something that's more aggregate, right? Like, maybe
in
something
the
where
perfect world, I can just tell Tempo, hey, give me a representative sample of my traces that include service A. The make it representative part is what's hard, right?
Right.
Tempo actually figuring out, okay, these two traces that look the same except some small difference in timings, I can throw one away, and stuff like that. It's like super hard.
That would be extremely difficult. What might make more sense instead of that is like, so a trace tends to have, the service name or other metadata that lets you know when it crosses trace boundaries, right? or sorry, service boundaries. So if we were to, maybe if the question were like, what are all the relationships and counts? Like, show me just give me a list of parent and child relationship in a query, and the number of times that happened. That might be something, right? That would be, I think, more tenable. Like, it would be a lot less data to return and more directed at what was attempting to be done, which is build a service graph, right? Of course, what else? What other kind of data are people using service graphs? Do they want latency? Do they want error rates? What else are people? I've never really used a service graph that I liked.
There's a bunch of things. There's like, what's my P50, P95, P99 latency between these two services? What's my error rate between these two services? How many times do I have to retry between these two services? And then also comes the question, how the heck do I tell a retry apart from a regular request? Like, there's lots of things there. A bunch of them, the answer is, make some metrics, record your metrics, go home. Like, that's a perfectly valid answer for a lot of them.
Right.
That's not a valid answer for a bunch of them, like actually generating the service graph and the dependency tree and like that level stuff. You can't do with metrics. So I think the focus should be, what can Tempo answer that metrics cannot, and kind of gear it towards that. Because for everything else, record it, damn it, and you'll be fine.
Yeah, I agree 100%. Metrics are just too good at storing what they're supposed to store in terms of like compression or the size you can keep them on disk and how fast they are to query and scan and do all these things. Generating metrics out of traces is like a last resort. Like, here was a metric we couldn't capture due to cardinality or some other reason, or we just don't have a metric for yet, and we want to ask a question that our metrics don't answer just yet, or can't answer perhaps. And that's where you want to go query something like logs or Tempo for traces. So yeah, this is a cool idea. Definitely get an issue up, and I think it'd be a good place to chat about it. And yeah, I really want to meet your all's team and see what you've done internally. This is a really, really neat usage of Tempo for sure. Cool. I don't think I captured half of that in the notes. I tried to get some of it, but I got a bit there. Marty or Ananya or whoever, if somebody could try to help keep track of what's going on, I appreciate it in the meeting notes. For anyone who showed up during that whole conversation, we are just getting started on our community meeting here. Luna had some really good input on distributed, or like building graphs or other information on distributed tracing, as well as kind of pushing Tempo forward in terms of the queries that we can use with Tempo. Right now, it's just a key value store. We have an agenda in the document linked. Let me link it again in the chat for everybody who showed up after I did. Please feel free to add anything. You can treat this kind of call as a AMA or like a office hours kind of thing. Like, we're just here to chat. I do have some agenda items if anybody doesn't have anything directly to add. And also, this isn't really like a canned presentation thing. Feel free to jump in and talk whenever, and add whatever you have.
Another potentially interesting topic I have is doing tail-based tracing with Tempo. I'm not sure if anything there is planned, but I'd be surprised if it wasn't discussed before. Like, in my perfect world, everything I have in my clusters just traces 100%, and I can actually decide whether to save the trace or not, when I can look at it at the end as close to Tempo as possible, right? Has any work been done towards something like that, or?
Yep. So let's see here. So the trace pipeline in Grafana agent is based on the collector. Either fine to push traces into Tempo, but recently JP from Red Hat added support for tail-based sampling in the collector. So we're looking at also getting that to the agent and kind of playing it within our environment and trying to get a feel for, I suppose, how far it can scale, like how many spans per second is it going to handle, how much CPU does that cost in memory, and all these things. It's a little kind of, it's not obvious how to do it. And I think we want to try to help, make it obvious, put together some documentation to help see that. But it's split. Are you familiar with the OpenTelemetry collector? Have you messed with this thing at all?
Yeah, we're running it in like 10 plus clusters. So
nice.
Familiar out of necessity.
Right. Familiar out of necessity. That's right. So let me find closed. Oh, it's in the contrib repo, I think. So there's a tail-based sampling processor in the collector now, but it requires the full trace to go through one collector because it's not like right. So let's see if I can find that.
Though in practice, unfortunately, like the moment you deal with a cross-cluster request, you're back to, oh, I don't have my full trace.
Right. That's the first part. The second part is this is why I say it's kind of like it's a little project to put this together. The second part is this guy here.
Cross-cluster, you would need a OpenTelemetry collector in a central cluster where you can get these pieces from these individual clusters and then run a tail sampling process there. That would be huge, like egress, like network cost, just shipping so much data out of your cluster. And it would like beat the whole point of like tail sampling at all.
Right, cluster is another question. We can talk about that in a second. But inside of a cluster, these two pieces put together will give you some kind of tail-based sampling. We can't really talk to it because we've not used it, but we do want to experiment with it. The first one just does the actual work of trying to like batch up a trace in one piece and make a choice about whether to pass it on or drop it. And then the second one I linked actually attempts to route a trace to one collector. So it will batch up a trace, wait however many seconds, and then it will choose a set of downstream collectors is that upstream? Whatever. Downstream collectors to send the whole trace to. So the second collector can make the choice, right? Because it's supposed to have the entire trace. So you actually need like two layers of collectors. The first is like doing this routing choice. The second layer is doing batching up and making the tail-based sampling choice. Now that doesn't really fix cross-cluster. Like Ananya said, you would need like some central spot, right, where all this garbage ended up, and you had to do something.
Yeah, my thought was Tempo should have some kind of rule set, well, actually, I guess practically you could put a collector straight in front of Tempo running in the same cluster that gets the traces instead of Tempo, makes the decision and sends them along. But obviously, if you're using Grafana Cloud, that doesn't work. And you're introducing an extra point of failure, but that bit is expected.
My bad.
It's a pretty neat idea.
Thanks, Serge. You're right. I was wrong. I think I posted the wrong one. I thought this is the right one. I don't even know what the routing processor is. The load balancing exporter is what you want. What is the routing processor?
Yeah. So what Luna just mentioned is like sounds like a really great feature to add to Tempo, where you can say, hey, this is like an allow list of conditions that I need to have to store anything at all to the backend. Latency of my trace should at least be so much. We can add these conditions probably when we marshal into the trace object at, I guess, like the distributed level.
Yeah, that was my thought as well, where I can like say, keep all traces that either have errors or are from, in our case, we're in Embark Studio, so keep all traces that include an Embark user or have errors or, I don't know, are out of the P99 latency, which brings us back to the lovely metrics out of traces problem too. So, nice stuff.
I wonder, something we had talked about a long time ago, but haven't done, is kind of have a way to keep certain traces for just longer. So it's kind of interesting traces that have failed, traces that are latent or whatever. Keep them for a month, and traces that succeeded and are under your latency requirements you don't care about, get rid of them in 2 days or something like that.
Yeah, so you could kind of cool too.
That'd be kind of that way you can kind of keep everything immediately, and you can your trace to ID logs jump will still work all the time. You can feel comfortable with that. But then like when you're wanting to see certain information a month later, maybe you can kind of keep the things that make sense. We could kind of do that at compaction time. That's another really good idea for, yeah, you're welcome to make that issue as well. Please do.
Yeah, it's so many related things. Oh, sorry, Anna, go ahead.
No, go for it. Go for it.
It's really hard set of all related problems. Makes it really hard to also know like what's the issue here. Like the issue is I want to do tail-based sampling, right? But like you can do compaction time things, but like you described, that's good enough for most purposes, right? You're effectively tracing everything, but you're throwing away all the uninteresting bits after 2 days. As far as I'm concerned, that's tail-based sampling, even if it's 2 days later, right? or you can do it at ingest time, or yeah.
Yeah. We also kind of are trying to balance like changes we make for the open source product as well as for Grafana Cloud. For Grafana Cloud, it makes way more sense to put this in the agent, right? Because that's where people want. They don't want to send us the trace and pay for that, and then for us to drop it 2 days later. They're going to pay us to keep it. We may as well keep it the whole time. But for the open source option, for people who are running this in their own clusters, yeah, I think that would be really valuable to reduce storage costs quite a bit if you could do some kind of like filtering or whatever.
Even for the cloud offering, though, right? Like surely storing a trace for 2 days can cost less than storing it for 30, right? So it of course depends on the pricing model, but it could still make sense.
We'd have to change billing quite a bit, and that'd be really complicated billing. Well, maybe not. Like charge you for the amount you're storing. Right now, we charge you for the amount you ingest, right? Okay. Cool. So tail-based sampling, do it in the agent, do it as some kind of like process that drops it slowly over time, do it in the distributor, or sorry, the ingester would be the place we would do it, or maybe do it as like, like some kind of degraded thing over time. Oh, my children are screaming. If you can hear them, just let me know. Compaction. Cool. Let's see. So let's talk a little bit through this agenda here. 050 was released. That was released, I think, shortly after the last meeting, and we're going to say 060 is about to be released now. Marty or Nanya, do you want to go over the 050 notes?
Sure, yeah, I can do that.
Yeah.
I'll paste the link.
That's a good idea.
Right. Yeah, so I guess the biggest feature was support for Azure Blob storage. Yeah, so that was a community PR, I guess. So that was really cool to see that. The query front end was new in that release. Gosh, it's been so long, I didn't realize it was new in that release. But that was the very scalable way to query the data, right? The separate module that's independently scalable. So we did have a breaking change in there for the communication signature between distributors and ingesters. And so that means that it's a new endpoint that is on, the ingesters have to be rolled first to add the new endpoint, so we don't drop the old endpoint. So after upgrading the ingesters, then the distributors can be upgraded afterwards to kind of push to that new endpoint. Cool. Disk-based caching is removed. Probably is never a great idea in the first place. So the only options now are Memcache and Redis. Yeah, yeah, yeah. So this was another change to kind of help control ingester performance. So it can target. Oh, I'm sorry. Never mind. That's in 0.6. So a change here to just control some burst settings, and then other fixes. I don't know if we want to read through all those, but that link is there.
Yeah. Yeah. And then upcoming in 060, Marty, you had some good performance improvements. You want to talk about those?
Yeah, let me pull up that change log actually.
Yeah, I was going to grab the link. I'll link it here.
Hey, and Daniel added the Redis caching support, by the way. Daniel, you got to show us your tempo stickers. We don't have any, so.
Oh, yeah. Do you have some? I still don't have any.
Sure, yeah. So Well, one thing we're kind of working towards.
Nice.
Oh yeah, that's awesome.
I don't even have one.
Trying
Dang. All right, we need to have conferences again so I can get stickers.
There was who had a 3D printed tempo thing, or maybe that was a Grafana thing. I
It's
thought
either
we'd
Tom
see,
or Richie.
That was
Yeah,
Richie.
okay.
Yeah, Richie has it.
That was Richie.
I'll try and find it.
Right.
Are you talking about the coins?
I think so.
Yes.
I'm not sure.
Yeah, Richie can hook people up with swag, so at least stickers, at least if you're external to Grafana. So yeah.
Nice.
Yeah.
Tempo monies.
So
Yeah,
hit it.
I don't know how many tempo dollars that is worth, but it's probably a lot.
That's right.
If you have a printer,
It's Grafana Cloud credit.
Yeah. So in the next upcoming release, probably the biggest thing is compression of the storage. So that is significant. So the default right now is Z standard, but there are a couple of other algorithms there that may work better, for certain data. The savings, I think, were 75% reduction. So something like that. So, I mean, it's significant. So storage was previously the largest cost driver. So, I mean, I think that'll really help. And the overhead of Z standard is, it will use more CPU, right? So it is kind of like the heaviest algorithm, but like I said, there's multiple ones there that may work better if you need to. Yeah.
Yeah, real quick, I can share. Can I paste this anywhere? No, I don't think I can. Oh, I can put it in the doc. I can just push this in the doc. Yeah, one sec.
Just a question. Does that mean that the ingest price on the cloud offering will go down as well to match?
Not my department. So compression ratio for none, of course, you have 100% there, right? Yeah, we were taking a 2 gig block and we batch them, I think internally, well, right now it's by bytes, but at the time that was 200 traces per compression page, essentially. gzip was the most expensive one in terms of CPU, but it was also it wasn't even the best one. Z standard had the best compression and had like kind of a middle ground in terms of CPU cost, and so that's why we chose it. It was a little rocky at first. We had our queries and compactors and queries were just ooming constantly, just serious memory leak, which we fixed. And so what we consider kind of supported, I suppose, in Tempo is no compression, and Z standard. Those are the ones we've run at scale. Those are the ones we feel comfortable advising people to use. If you want to use Snap, I don't see any reason to just use gzip. It's in there, but it's whatever. If you want to use Snappy or LZ4, there is it will read faster. The compression ratio is not as good. But Snappy and LZ4 might be interesting for other people to experiment with. Please do, but know that we have not run it at scale internally, and there might be some memory or other kind of resource issues.
And there are a couple different block sizes for LZ4, and I think those are documented in the config options.
Yeah.
Cool. So there's some additional compression changes for the traffic. So another area I guess we keep looking at is between the distributors and the ingesters, because that's the critical path for data flow. And so we're changing the compression there from gzip to Snappy. So those are there are more limited options there, but Snappy performance is looking better.
Yeah.
Yeah. I guess what else out of the next upcoming release would be good to talk through?
Excuse me. Ananya's finished Exhaustive Search. So query frontend was added in 050, but Exhaustive Search is a cool feature, which is it's on by default. You can't even turn it off at the moment. Yeah. You're required to run it exhaustive at the moment. Ananya, do you want to talk about kind of what that looks like?
Sure thing. So this was what we were looking at with the query frontend, right? That's what we wanted to do when we introduced the query frontend. We wanted to combine traces that could have been split across blocks for a number of reasons. They could be across compaction windows. They could be long-running traces that could be part of multiple blocks. And we wanted a way to combine all of them and return the full trace. And that's now possible with the query frontend. And we're searching for traces in all of the blocks in parallel. And it works really well. our latencies are still as good as they were when we were at replication factor 2 with 150,000 spans. We're now close to 400,000 spans per second internally, and our latencies are, I think, 99th percentile is around 2 seconds. That's like pretty impressive for like a parallel search, I think.
Yeah. What were those stats, Ananya?
Let me get the accurate numbers.
Sure.
So let me bring up our internal dashboard.
Oh, it doesn't have to be perfect, man. Sorry. Well, I guess the point I was going to make was I wanted him to reiterate for a second, and then our current, to give you an idea of our scale internally, is we're searching 13 billion traces over a 14-day retention window. So whatever, I didn't exactly catch the latencies, but whatever they were fantastic, and it's over that size of data. So whenever you're kind of running Tempo yourself, you're kind of making a call about like how much volume am I ingesting, what retention do I want, and that turns into how long my block list is, and that really is the driver for your latency. So you could do significantly higher volume with a 2-day retention, or you could do lower volume at a 30-day retention, and your query latency is going to be, you can kind of balance that against your query latency.
Yep, and the number of queries you run, I guess, like the size of the query deployment, that would, that would also factor in. So, okay, accurate numbers. We are at 1.6 seconds at 90th percentile, and our average is well below a second. Like that's cool. 700 milliseconds, I guess. 50th percentile average. Yeah. Pretty happy.
A question on that: is there an upper limit to how long a trace can be in Tempo? Like, am I going to get in trouble if I record a 5-hour trace, theoretically speaking?
But this actually helps fix that, right? Whereas normally that would have been split across multiple blocks because there's that trace idle period time where it will be cut. And so this will bring it all together and combine it fully. So different parts of this have been released in different places, but this was finally going to, no matter how many blocks it's split across, it will bring it all together and combine it. Right? Yeah.
So I guess the short answer then is there's no limit.
Well, just kind of the end of your retention window, essentially.
Yeah, I'm not sure how the Grafana. Yeah, I'm not sure if the Grafana UI handles traces that are too long. I'm not really sure.
We should do that.
Looks like we should try that. Yeah.
We should make 1 span a day for a trace for 2 weeks and see what it looks like.
Yeah, 1 span
a day. Something I think we've seen a little bit more of in the community is wanting to trace longer processes like CI pipelines or other things that take batch jobs that take hours. And initially Tempo didn't handle that well, but with Ananya's recent changes, it does. And so we're meeting that need as well with this release with SXO.
Yeah, in our case, it's mostly streaming gRPCs where it may be a while. But yeah, cool. If it can handle hours with CI, then that's not going to be a problem.
Cool. Ow, cat. Let's see. So 060, exhaustive search and compression. We have 2 blog posts. I wanted to highlight these. For people who are kind of getting started doing some instrumentation, Marty wrote a nice post here, and I wrote one from before that's certainly not as nice, but I should probably make these links instead of this horrible giant thing. The first one is Spring Boot. The second one is .NET. So if you're using any of those technologies, you can see some good examples there, how to set it up with Tempo, how to instrument applications. I think maybe the people on this call are a little bit past that. We're trying to just create more material that gets people involved in Tempo. If there's any languages or frameworks that you all are aware of that we could add, we kind of are trying to target popular things, right? To drive some attention to Tempo, get more people more training on instrumentation. But I don't know, what else? Perhaps the question for the group is, what other kind of frameworks or technologies do you think are very popular that we could like benefit from a blog post like this.
So another thing to think about as you guys are working on documentation is our lovely go-to-market Cloud Writer is basically is working on making tutorials and stuff that pulls stuff together, but it really helps him to have raw material to start from. So if you guys make more raw material, odds are higher that he will be able to go in and help make something cool and multimedia from that. So,
Sure.
good for that.
Sure. For a lot of these, we're trying to just, I think, get people started. There's a group of people who are interested in tracing, right, who don't really know the beginning of the process or what tracing is. And these are meant to be like an opportunity to draw people in. And we chose .NET and Java particularly for that reason. There's lots of, you know, on enterprise Java developers, it's extremely popular. Spring Boot's very popular. .NET's very popular. And we want to attach or connect to those communities and kind of give them material to get involved in tracing. I don't know if, I mean, for me, those are two of the most popular, huge, you know, kind of languages. Is there, what else could we do? Python? Do people still make Python backends?
Yeah.
Regarding Python and Rust, which I mentioned as well, what could be also very interesting for those languages in particular is they're often used to make things that talk to backends. And initiating a trace from there can also be really interesting, since you can actually, well, you can start getting tracing data earlier, even if you don't entirely trust the client. You can do some interesting things, like starting a span.
Yeah, we recently connected Grafana, like the trace from Grafana all the way down through Cortex, and it's really neat to see the span start in the front end and go all the way through the back end and all the way back. I don't think we fixed that in Tempo. I mean, it's not broken in Tempo. It's, I think, just span or trace propagation that we need to figure out that we just haven't done yet internally. And then Rust. I've always wanted to fool around with Rust. I've never done anything with it. Is it? I guess it's kind of a growing community, and I don't have. I guess there's clients. Jaeger Rust client. I'm going to Google that right now.
There's an open telemetry Rust client of some sort, and there's also some. There's some language-wide efforts in just introducing tracing as a provider-agnostic concept, which are currently in the works. So it could be interesting to plug into that.
Are you saying like open tracing, like where they kind of standardize the API? Is that something like that?
It's actually above that, where they're kind of trying to standardize it as a language. Let me find a link.
Yes, please.
Hey, Lucas, you want to talk about the auto instrumentation stuff from Python? That sounds really cool. Do you want to walk us through how you're using it?
Sure. I mean, I don't really know what to say. We mainly just kind of like followed through the examples. We started with, we've got like a Flask app that then, you know, talks to a number of data sources, Mongo, Postgres, Redis. I believe the Postgres one was the only one that we didn't get working fairly quickly. So we basically did a combination of the Flask app using the Flask auto instrumentation, various data stores using the auto instrumentation, and then the backend Python stuff was all manually instrumented. That's not Flask based. So
cool.
I can probably find some code snippets. What's that?
Can you teach us how to do it?
Can I teach you how to do it? I'd have to go back and dig out our examples. I mean, I don't know. A lot of what we did was from the Open Telemetry Python documents. So yeah, it's one thing with the Python stuff is definitely it tends to matter how you're passing through the thread context and such, and that seems to be pretty app specific in my experience. So I'm by no means a Python expert, but I can help provide some examples if that would help y'all guys along. So
cool. Yeah, if you have some links to share in the document, please do.
Personally, I'm curious. How are you like logging the trace ID with the Python auto instrumentation? Because I raised an issue on the OpenTelemetry client because they don't have that option. So how do you discover traces on your Python apps?
Sorry, I couldn't make that out. Could you repeat it? You're like really soft on my side.
I mean, how do you discover traces using Python auto instrumentation? Because you can't log the trace ID right now. So
Yeah, so that's definitely one of the things that we had to work on, and we did it through logging. So specifically, like putting the trace ID into, like, if you use struct log, you build kind of like a logging context, and then so you start your instrumentation, and then you build the logging context for struct log, and then basically you process the rest of the request through that. And then the data source auto instrumentation will obviously, like, it will pass through the trace context, or I forget the exact name. But anyway, the data sources should pick up the parent trace ID for you. It's mainly just getting the initial log message out that has that. And yeah, that does depend. Again, that's kind of like Python specific to what you're doing. If you're doing something with a lot of forking, then that can kind of, like, obviously change how you do it. But in the example, or like it also too, if you're like doing G Unicorn Flask, I don't even remember the workaround that we did for that. Somebody else did that one. But passing that context back and forth by invars can, that's one possible solution. But yeah, you definitely have to start the trace and then create your kind of your logging context, and then just pass that trace ID through with all the logging context.
nice, thanks.
I always pronounce that Gunnicorn. I have no idea. I've never actually used it. It's G Unicorn.
It's supposed to be like the Ruby Unicorn project, right? And then they ported it to Python, and so I always called it G Unicorn. I have no idea. That's what I call it. So.
Sure. My experience with Python is pretty limited, so I'm definitely not the expert here. Cool.
Should totally be Gunnicorn, because that would make an awesome logo, like a unicorn with a cannon on his head.
Yeah, I'm gonna second that one, so it's now official.
Cool. Okay, Python's a good target then. We can look at that. I'll kind of put out my personal notes. I've always wanted to mess with some of these languages, and it's kind of building these blog posts and these repos kind of gives me an opportunity to dig into some of these frameworks and languages I don't have a lot of experience with, which is cool.
Maybe a hack day project, Joe?
Every day's a hack day.
Words to live by.
Cool. Let's share some internal metrics here. So just to show how we are running Tempo, I'm going to do some screenshots, I guess, of our internal guy. We are around 450,000 spans a second, which I'm happy with. I really wanted to push towards 1 million, but we could. It's one of those things where we could, but we don't need to, and the cost would be more than we want to pay right now. Compression changes, as well as some other changes to the query path that we're going to work on, I think are really going to make 1 million spans a second without scaling our current cluster feasible. And so that's going to kind of be the goal. 060 is going to drop TCO a ton for those of you who are running Tempo. And then we're going to see further improvements, particularly on the way we query our backend in the next couple, I'd say, month or two. So we're about 450,000 spans a second. It's about, I think, 7,000 to 8,000 traces a second. I think our average is it about 100? I always think 100, but now that I'm saying it out loud, I want to make sure the math works.
It's more about 17,000 traces per second.
That's divided by 2, because it's after replication factor.
Oh, okay, cool. Never mind.
And then we're looking at, let's say 420,000. So we're at 50. Okay, yeah, we're about 50 spans per trace. I don't know what other people are seeing in terms of spans per trace. We were at 100 because our query path is much larger, but we started to sample larger and larger percentage of our write path, which is smaller traces. So our spans per trace is going down. Are people seeing? I don't know. I really don't know what the expectations are here. I've only done tracing at Grafana. So what can people share? Like, do you know how many spans per trace you have on average in other places? Or does nobody know? That's also possible. Or it's super secret.
Ours varies quite a bit. In some cases, we have like 3 or 4 spans per trace, but then we've had traces that were probably like 80 is probably closer to the average, especially when you're instrumenting all the data store calls. But we've had traces as large as 1,700 on kind of like longer running things that do a whole lot of data store queries.
Okay.
Hopefully that's not going to be the average, but we'll see.
Right. So let's see. Our average is 50, but our largest traces hit several 100,000. In fact, if you look at that thing I linked, the spans per second, you see some yellow refused spikes. Those are spikes because generally Loki is crossing the 350,000 span border. We have a current limit that prevents, a kind of a max on spans per trace, and it's always Loki. So those refused spikes are somebody querying a huge query in Loki, basically. But yeah, so yeah, in the thousands is no problem. I think our query path is in the tens of thousands. Are we there, Marty and Anya?
Tens of thousands. Yep.
Yeah. Okay.
I saw some with 12,000, 13,000 is normal. Yeah.
Okay. Sometimes I wonder at what point it becomes useless to have a trace, at least to just look at it in Grafana. At what size it doesn't even matter that you have this whole trace. But I also think for some of the things Luna was talking about earlier in terms of service graph building, having that data is valuable anyway to do kind of analysis kind of work. Maybe not staring at a couple 100,000 span trace, but just using it as data for some kind of other job, metrics or whatever. We are close to time. I was going to kind of talk about our roadmap to GA, but let's not get into that. 050 was released. 060 is coming up, and we'll have really good TCO improvements. Let me open the floor for some final thoughts or questions from anyone else, and maybe we can save kind of a roadmap to GA for next month, at which point we might be done with the roadmap to GA, or at least close. Cool. Okay. Well, thank everyone for coming in and showing up. I wish Luna didn't have to run. I wanted to thank her for getting involved and sharing her work at Embark, and hopefully I'll meet those engineers soon. Thank everyone else for also joining, and we will see you in a month, hopefully.
Thank you.
Take care, everyone.
Hey, thank you.
Bye.
Bye.
Bye.